Hello, so in this video we will talk about the Laplace distribution and we will specifically try to evaluate the mean and variance of this random variable. So by definition, a random variable x is said to have a Laplace distribution if the PDF is given by a 1 over 2 alpha e to the power of minus absolute value of x minus mu divided by alpha, and the support is all real numbers. Okay, so before we start deriving for the mean and variance, we'll make use of these two identities. So this is just integrals, and you can solve it by integrating by parts, and this is not the purpose of this video. So but this is what you can actually check by integrating by parts. So we will use of this integral and this integral, as we will see. So let's start off with the mean first. So e to the x, this is equal to minus infinity to infinity x fx dx. This is equal to minus infinity to infinity x e to the power of minus x minus mu over alpha dx, and then we have 1 over 2 alpha here. Okay, so this is equal to, now what is this guy? So x minus mu, this is equal to just x minus mu if x is greater than mu, and this is equal to minus x plus mu if x is less than mu. Okay, now if I put minus here, I have to put minus here, plus here, plus here, and minus here, correct? So this is what we are going to use. So we are going to split this integral into two regions, x greater than mu and x less than mu. So then this becomes e to the x becomes 1 over 2a, 2 alpha minus infinity to mu. So this is this guy. Then we have x e to the power of x minus mu divided by alpha alpha plus 1 over 2 alpha mu to infinity x minus yeah, x e to the power of minus x plus mu over alpha dx dx, right? Okay, now what we can do, now we can bring this e to the minus mu over alpha out and e to the plus mu over alpha out. So then let's write it here. So we have e to the x, this is equal to 1 over 2 alpha, then I can say e to the minus mu over alpha minus infinity to mu e to the x over alpha, and we have x here dx plus, now here I can say e to the plus mu over alpha mu to infinity x e to the minus x over alpha dx. Okay, now I will use this guy here. So this guy I can use, I can say 1 over 2 alpha. Now this is, now what is a here? A here is 1 over alpha, right? So I can say x e x over alpha divided by 1 over alpha minus e to the x over alpha divided by 1 over alpha squared, correct? Now plus e to the, and this is from minus infinity to mu, and then I can say e to the mu over alpha. Now here in this case a is what? A is minus 1 over alpha. So I can say x e minus x over alpha divided by minus 1 over alpha minus e to the minus x over alpha divided by minus 1 over alpha squared mu to infinity, and we have bracket close. Okay. Okay. Now we have 1 over 2 alpha here. So e to the minus mu over alpha. Now what do we have? Now we can put mu here and I will get mu e mu over alpha, and this 1 over alpha is in the denominator, so I can say just alpha minus e to the mu over alpha, and then 1 over alpha squared in the denominator, I can say alpha squared. And then if I put infinity minus infinity here, then this goes to 0 and this goes to 0, because e to the minus infinity is 0 and e to the minus infinity is 0, so I don't have to write anything here. Okay, so then I can say plus e to the mu over alpha, and then this guy is what? So then I can say, if I put infinity here, this goes to 0 and this goes to 0. Okay, but if I put mu here, then I have to minus here, right? So because upper limit minus lower limit, so I have to say minus, and this minus will cancel out, so I will say x, not x, mu e to the minus mu over alpha times alpha. Then we have a minus because of the lower limit, another minus here, and this minus is cancelled, so we have two minuses, so this is a plus e to the minus mu over alpha times alpha squared. Okay, so just to repeat again, so this is a plus here, so but this is a minus here, and this is a lower limit, so another minus here, so that's why we have a plus. This is a minus here, this is a plus here, and this is a lower limit, so this is subtracted, so there are two pluses here. Okay, so now it's a matter of just algebra here, so it is 1 over 2 alpha, this e to the minus mu over alpha, and this will cancel out, I will be mu alpha, and then this will be cancelled out with this, and I will be left with minus alpha squared, then plus, and this will be cancelled out with this, I will be left with just mu alpha, and then plus this will be cancelled out with this, and I will be left with just alpha squared. So this will cancel out, and I will have 1 over 2 alpha mu times alpha times 2, because I have 2, right, 2 here, so this is equal to mu. So this is my mean of the Laplace random variable. Okay, so now we are interested in the variance here. So variance of x, this is equal to e to the x squared minus e to the x squared, correct? So e to the x is what? Mu, so I can say is equal to e to the x squared minus mu squared. Okay, now our job is to find e to the x squared. So the e to the x squared, this is equal to 1 over 2 alpha minus infinity to infinity x squared e to the minus x minus mu absolute value dx, correct? Now we use the same story, we split the integral, we say minus infinity to mu, we have x squared e to the x minus mu over alpha dx plus 1 over 2 alpha mu to infinity x squared e to the minus x plus mu over alpha dx. Okay, so then this is equal to 1 over 2 alpha, I can say e to the minus mu over alpha minus infinity to mu e to the x over alpha x squared dx plus e to the mu over alpha mu to infinity e to the minus x over alpha x squared dx. Now I will make use of this guy in these two integrals. Okay, so then what we will have e to the, so 1 over 2 alpha then e to the minus mu over alpha. Now this is what is my a? A is 1 over alpha, so I'll just go and put it here. So x squared e x over alpha divided by 1 over alpha minus 2x e to the x over alpha divided by 1 over alpha squared, sorry, not plus, minus, so plus 2 e to the x over alpha divided by 1 over alpha cubed. Okay, and what are my limits? My limits are minus infinity to mu. Then I have the next term, so e to the mu over alpha is out. And what is my alpha? What is my a? My a is minus 1 over alpha here because of this guy. So then again, x squared e to the minus x over alpha divided by minus 1 over alpha minus 2x e to the 2x e to the minus x over alpha divided by minus 1 over alpha squared plus 2e minus x over alpha divided by minus 1 over alpha cubed. And what are my limits? My limits are mu to infinity. And then I have a bracket close, which I'm not writing because of the space. Okay, so then this is what? 1 over 2 alpha e to the minus mu over alpha. Now note that again, for minus infinity, all of them will go to 0. So I'll just write the mu term. So I have mu squared e to the mu over alpha times alpha because of 1 over alpha here. Then minus 2 mu e to the mu over alpha times alpha squared, then plus 2 e to the mu over alpha times alpha cubed. Okay, then I have what? I have plus. Then I can write e to the mu over alpha, and then again for infinity they all will go to 0 because we have a e to the minus x here, and for the mu we will write the same thing but with the negative sign. So now we have mu squared e to the minus mu over alpha times alpha. Why times alpha? Because one negative here and one negative because of the lower limit. Then again one negative here, this is a positive, and then one negative here, so again a plus. So plus 2 mu e to the minus mu over alpha times alpha squared. Then we have a negative here, we have a negative here, and we have a positive here. So then again a plus. So plus 2e minus mu over alpha times alpha cubed. Okay, so then what do we have? So then we have 1 over 2 alpha. Now this will cancel out with this. I will have mu squared alpha. Now this will cancel out with this. Then I will have minus 2 mu alpha squared, and similarly I will have then plus 2 alpha cubed. Then I will have plus just mu squared alpha again, mu squared alpha plus 2 mu alpha squared, and then plus 2 alpha cubed, which is equal to 1 over 2 alpha. Now this will cancel out with this guy. I will have 2 mu squared alpha plus 4 alpha cubed, which is equal to mu squared, because this will cancel out with this, or except mu squared, and then we will have plus 2 alpha squared. So this is my second moment. If this is my second moment, what is my variance? So variance is equal to the second moment, so mu squared plus 2 minus the mean squared. So mean was what? Mean was mu. So mean squared. So my variance is 2 alpha squared. So this is the variance of my Laplace random variable. Typically, a Laplace random variable looks like this. So it looks like this. It has a sharp, sharp curve like this. So it's symmetrical about the mean, but it's, I mean, the Gaussian is like this, like a bell shape, but the Laplace is like this, like it has more sharpness here. Okay, so this is it about, it was to find the mean and variance of Laplace distribution. It was pretty straightforward. We have to repeatedly apply some integration rules, and these integration rules you can find in the textbooks, or you can actually do integration by parts. I would recommend do integration by parts and derive it yourself to have a good practice of how to integrate by hand. So this is it about the Laplace distribution. Hope you like the video, and thanks for watching.